Hi, welcome to part 3 of our trigonometry. This will be the final part of our assignment. In this part, we will look into the trigonometric identities. In the previous part, we studied trigonometric ratios with certain values. Now, based on that and all the identities that we have studied till now, in this part, we will be defining the first 3 important trigonometric identities. Alright, so these are the basic trigonometric formulas which you will have to remember for the rest of your life. So stay tuned in part 3 and let's look into the video lecture. Hi, continuing from the previous part, in this part we'll look at the trigonometric ratios for some specific values, for some specific angles, but in terms of the complementary angles. Now how do we look into that part? We understand what are complementary angles, right? Complementary angles are those angles whose sum is less than or equal to 90 degree, right? So in this case it will be actually 90 degree, right? So in a right angle triangle, if this is my 90 degree, this angle and this angle are my complementary angles. So if this is theta, this would be some other values, okay, which would be 90 minus theta, right? So basically in this part we'll be studying about this angle and the values for that. Now, as we know that in the triangle ABC, it is right angle at B, we have 2 complementary angles, right? So I have angle A and C is equal to 90 degree. They form such a pair. So I have my sine, cos, tan, cot, sec, cosec, they are all defined, right? So up till now we took out the trigonometric ratio of angle A. Now let us write a trigonometric ratio for angle C, that is 90 minus angle A, which we shall write as 90 minus A for convenience. Okay, so if you look at that part, how do we come to this? Now what would be the side and what would be the side opposite and adjacent to angle 90 minus A? We need to figure out that. So for all these cases also we will draw a diagram. This is my A, this is my B, this is my C, and this is my angle which is 90 minus A. So for angle C, the opposite side becomes AB and this becomes my adjacent side. So over here now, hypotenuse remains as such, this becomes my perpendicular and this becomes my base. So what is happening in this case? Very interesting revolutions are going to occur. So my sine 90 minus A, I can write it like this. I define all the values like this. Okay, I have taken out all the values. Okay, I can do that. I can simply write this triangle. Okay, I have my values have just changed. My hypotenuse remains the same. My base and perpendicular have interchanged. So, you know, the trigonometric ratios are nothing but the definition of perpendicular and base, right? So I have written down all of them. Now, if I compare this one with all the trigonometric ratios that we have already defined, you can see that my sine 90 minus A is actually equal to my cos of A, right? And simultaneously my cos of 90 minus A will be equal to sine of A. So this leads to our trigonometric identities. Most important trigonometric identities. Okay, so from this I can write my tan 90 minus A is cot A, cot becomes tan, sec is equal to cosec, cosec is sine. Okay, so like this, if I define all of them, I get all the different values. Alright, so for all the values of angle A lying between 60 and 90, check whether this holds true. Obviously it will be true. If you remember that we had defined value for cos 30 degree to be equal to sine of 60 degree, right? If I write it as sine 90 minus 30 degree, and if I write 30 as A, it basically defines this whole formula, right? So like this, the trigonometric ratios, the table values will always correspond with respect to these formula. Alright, moving on, we need to remember that since tan 90 was defined at 0 as 0, so it will also continue like this. Sec 0 was defined at 1, which will be equal to cosec. Sec 90, cosec 0, tan 90 and cot 0 are not defined. Okay, so simultaneously those values will remain unchanged. Okay, now, so if I have in a right angle triangle, which is right angled at B, I have my AB square plus BC square is equals to AC square. Let this be equation 1. Okay, I divide all of them by AC. What does this lead to? You see, if I write them in terms of my trigonometric ratios, I'll have cos square A plus sine square A is equals to 1. So this defines my trigonometric identity as cos square A plus sine square A is equal to 1. So this is the most important trigonometric ratio that you need to remember. All the previous ones we had defined, those are in terms of formula derivation. This is the most important trigonometric identity that you need to remember. So this is true for all A's, for the case that my angle A will always lie from 0 to 90 degree. Okay, this value, this identity holds true only for 0 to 90 degree. If the angle is greater than 90 degree, then this might not exist. Okay, but since at your level we are studying only the angles from 0 to 90 degree, you should remember by heart that cos square A plus sine square A gives me as 1. Now, this is, let us continue with this part. Now, I have this, right? So, similarly, if I keep dividing with different sides, I can come up with different values. This is the second value for that. So 1 plus tan square theta is equal to sec square theta is the second trigonometric identity that you need to remember. Tan square A is equal to sec square A. Like this, if you continue, it will be like this. Now, is this equation true for angle at A equals to 0 degree? Yes, it is true. And what about 90 degree? If you look at tan A and sec A, they are not defined at A equals to 90 degree. So, it is true for all A for 0 to 90 degree again. Okay. Let's say if I define this again, when I divide them by the third side. So when I divide the ratio by the third side, I will have my cot square A plus 1 is equal to cosec square A, which is my third identity. Okay. So remember all the three identities that we have just seen. Okay. Sine square A plus cos square A equals to 1, 1 plus tan square A equals to sec square A, and 1 plus cot square A is equals to cosec square A. The three important identities based on which you will be asked different questions. Okay. Now we need to note that sec cosec A, cot A are again not defined at A equals to 0. Therefore, it is true for all the cases over here. Alright, using these identities, what do we do? Why are these identities important? We look into these identities because each trigonometric ratio is unique and it is also related to the other trigonometric ratios. So if we know one trigonometric identity value, we can probably calculate all the trigonometric ratio value. How? Let's look into the example for this. Okay. Let's suppose I have my tan A is defined like this. Then I need to prove that my cot A is 3. So what happens? I use trigonometric ratios. Okay. I know I can take out sec square A using 1 plus this. So I can calculate my sec value from this. So if I use that, I get my sec will be equal to 2 by root 3. Right? If I solve this, this will basically give me sec A at equal to 2 by root 3. Right? And I get my cos A will be equal to root 3 by 2. Again, if I have sin A is equals to 1 minus cos square A, I apply that. Therefore, my cosec A will be equal to 2. Right? So if I basically know one trigonometric identity, I can apply it anywhere, right? And I can get different values of the trigonometric ratio. So that is all in the part 3. Stay tuned for more lectures. Thank you. So guys, that was all in the trigonometric chapter. Now in this part, we studied all the trigonometric identities, the basic trigonometric identities that you need to remember. Now the values or the formula such as sin square theta plus cos square theta equals to 1, 1 plus tan square theta equals to sec square theta, all these values are the most important ones that you need to remember for the rest of your life. Based on these formulas itself, all the future formulas that you are going to study in trigonometry are based. Also, the formulas such as sin 90 minus theta is equals to cos theta and the formula set of these are also very unique and very important. Up till this level, you need to remember this only. When you move into the higher classes, you will get to know for 180 degree minus theta, what would be the corresponding value. So guys, that was all in our trigonometry chapter. In the part 4, we'll look into some of the questions that have previously come in CBSE exams from this topic. So stay tuned for part 4.